The last time I looked out here, there was a much bigger crowd. That's unfortunately comes with the territory of being the last speaker. But I know that it's a nightmare getting out of this place late in the evening, so I don't blame anybody for bailing out early. Yes, stay please until the end, guys. I'll be quick. I'll be brief. I'm Tony Flanagan from Schivo 3D. And I want to talk a little bit about the evolution of our industry from 3D printing to additive manufacturing. Obviously, very, very briefly, and I want to explain our position within that. Now, Schivo 3D is part of the Schivo Engineering Group. We're a company based down in Waterford, a precision engineering company. That's what we have been traditionally, and we've expanded over the past few years. We now have several facilities in Waterford, a facility in Derry in the north of Ireland, and a facility in Leicester in the UK. And the sectors that we tend to focus on are aerospace and the medical device sector. Also then some automotive and general industrial sectors as well. One of the key things about Schivo as a group, and it's one of the key reasons that actually Schivo 3D was set up, was we're very, very, very strong on the certification of our processes. 13485 for medical devices, AS 9100 for aerospace, certification for Airbus, Rolls-Royce, Bombardier, etc., etc. Now, that's very, very good for, I think, any engineering company, but for a company working within the 3D sector that also has that type of certification is very, very unusual. And that's a key thing in actual fact as to why we came into being as part of the evolution of the industry. So basically, Schivo 3D was set up when we were approached by Stratasys Direct Manufacturing. And Dermot's mentioned Stratasys, we've heard it being mentioned several times already today. Stratasys is the largest 3D printing company in the world. 2014, $800 million worth of revenue. And if you look at the development of the industry, the core 3D printing technologies were all developed in the mid to late 1980s. Initially, stereolithography, SLA, then laser sintering, and in 1989, Scott Crump developed the FDM technology and he set up Stratasys. And for me, there's been a whole lot of key moments in the development of the industry. That was really one of the key moments, because with SLA and with SLS, the materials that were developed were essentially plastic-like polymers, nylon-like polymers. But with FDM, what you got was materials that were genuine thermoplastics, the same as you would get if you were working within the traditional manufacturing sectors, ABS, polycarbonate, and so on. So where companies or customers wanted to use a particular product with the material properties of existing manufacturing technologies, they now had the option of choosing that material within the additive manufacturing sector. Now, I think if we look back at the history of our industry, from the 90s to the noughties, really what we were doing was we were inhabiting this space here. Prototypes, concept models, one-offs, proof of concept parts, demo parts. Because to be honest, for most of our history, what we did was called rapid prototyping. And to be honest, that reflects the limitations of the technology at the time. It had a lot of limitations. If you bought a part from us 15 years ago, it would have been a prototype. If you came back 6 months later and ordered the exact same part, you would probably see some differences between the two parts, because, you know, it's just a prototype. But what we've really seen, particularly I think in the past 6-7 years, is a huge evolution, particularly in terms of the materials. There's lots more machines available now. There's bigger machines, there's smaller machines, but really it's the range of materials that are available that have driven the evolution of the technology. And when we speak about 3D printing and additive manufacturing, people sometimes ask, is that simply terminology or semantics? But for me, it's not. When we're building prototypes, one-offs, concept parts, which we still do an awful lot of, we still very much inhabit this space. For me, that's 3D printing. But when we're printing parts that are actually part of the manufacturing process, that help you to create a product, or that's an actual end-use part that's in use 24/7, that's additive manufacturing. And if you're coming back looking for quantities of parts, that's additive manufacturing. And the reason that Stratasys came and chose a company in Ireland was really because of our strong certification base. Because the types of customers that are looking for additive manufacturing are some of the global marquee names. And if you're putting parts in cars, putting parts in the sky, you need to have an understanding of manufacturing processes. So what's 3D printing or additive manufacturing doing today that it wasn't doing in the past? Today we're printing parts, like Trina said earlier on, that are going inside the human body. We're printing pre-op parts for surgeons to work on before they actually go into the operating theatre. And what we see here is a lady in the USA last year, and what she's holding in her hand is a model of a brain aneurysm, her brain aneurysm. And she was admitted to hospital with headaches and nausea and dizzy spells. And the surgeons identified that she had an aneurysm, and they came up with several potential operating procedures. And because of the advances in materials, they were actually able to 3D print a model of her aneurysm using a material that had the same properties, essentially, in terms of flexibility, as a vascular model. And they carried out a number of pre-op procedures on the model, all of which failed. A few years previously, they'd only have discovered that when the patient was actually in the operating theatre and she would have died. So that's an amazing advancement. We're printing clothes, we're printing shoes, we're printing buildings, we're even printing in space. As you can see up here in the space station, where they have a 3D printer. So again, if I go back to this particular evolution model, what I would say is I've never seen anybody in my industry say that what we do will replace traditional manufacturing. What we do is complementary to traditional manufacturing. It's another option. And what we say is, it's like when you do a job at home, you open your toolbox, you find the best tool for the job. It's the exact same with our process. In some cases, the benefits that we will bring to creating a product or developing a product will be much more interesting and much more beneficial than traditional manufacturing methods. 3D printing, what we say is that its value is not simply as a technology, but as an enabler. It enables the development and manufacturing process. It brings different values. It doesn't simply define innovation, it actually enables it. And I think, as Ramesh said, one of the things that you can do when you look at what 3D printing can offer, you're not simply creating products in a different way. We get customers coming to us sometimes and they say, here's a part I'm machining currently. If you guys print it for me, will it be cheaper? And we turn it around and we say, well, why are you looking to print this part in that particular way? And you've got a part that potentially is being designed for another method that would be much more expensive to print, but if you look at it from a different perspective, you would look to redesign the part. And you would end up with a part that would be much more efficient, would have channels, would have less material, would be cheaper to print, would be more efficient as a part because you're designing it in a different way. So the exact same outcome in terms of the functionality of the part, a completely different process to manufacture it, but requiring a completely different mindset in terms of how you design the part. What are the benefits of 3D printing being? It brings different benefits to the entire manufacturing process. Why hold inventory if you can print parts on demand? If you've got product in the field, why would you hold spare parts where you can print those parts when the part actually breaks down at source if need be? Why hold parts in Ireland that you're going to ship to Europe or the States or Australia when you can have it 3D printed there and you can print the parts on demand at source? And I want to look just at a couple of examples of how companies are using 3D printing in innovative and interesting ways. And what we see today is that 3D printing companies, we see companies from startups to some of the biggest manufacturing companies in the world using 3D printing in additive manufacturing. This is a really good example that I like an awful lot from BMW. BMW are one of the biggest users of 3D printing in Europe. They print many, many thousands of parts per year. And they had an issue a few years ago where they had a jig, very, very simple jig, doing something very, very simple, putting the badge on the BMW car. But it was machined from a big block of steel. It was very, very heavy. And what they found was that they were getting a lot of operators with injuries, repetitive strain syndrome. So they were using 3D printing an awful lot. So they said, can we redesign this to make it suitable for 3D printing? So they redesigned it. And what they found is, apart from mitigating the incidence of operator repetitive strain and injury and so on, they were actually able to reduce the lead time to build the part from 18 days to less than 2 days, and the cost was reduced by 60%. So when they saw that, they started to look around at other health and safety issues, which is not what you would normally think about with 3D printing. You would think, 3D printing is for manufacturing, etc., etc. And they had another issue where they had an awful lot of operator injuries. And they developed something that the media called the magic thumb. or the super thumb. And basically, it's a it's almost kind of a silly issue. Every car has a plug that gets put into the base of the chassis. It can only be put in with the operator's thumb. And they were getting these big blokes here, as you can see, getting an awful lot of injuries with their thumbs. So what they do now is they scan every single operator's hand, and every operator gets a bespoke 3D printed thumb that they put on, just pop in this little plastic plug. But what they saw was a huge then reduction in the amount of injuries they were getting. And this is my favorite one. It's my favorite one for a couple of reasons. It uses my favorite 3D printing material, which is Ultim 9085. It's UL 94V0 certified. If anybody works in the aerospace industry, this is the only 3D printed material that is certified for use on commercial aircraft. And Airbus, when they delivered the A350 XWB at the end of 2014, they were having supply chain issues. If you work in aerospace, you know that if you miss your deadline to deliver airplanes, you get hit with absolutely massive fines. So they were having tooling issues, and they decided to turn to FDM, Ultim 9085, to print parts quickly. And the first planes delivered actually had over 1,000 3D printed parts on them. They saw a weight reduction in terms of the weight of the aircraft, and in aerospace, weight equals cost. But also, they had the 1,000 parts printed within a month, which would have taken 6 months using traditional manufacturing methods. So, what I would say is that today 3D printing is all around us. It is literally all around us. It's in the cars we drive, the planes we fly. It's in hospitals, helping to save lives every day. It helps designers design better products. It helps manufacturing companies build products more efficiently. 3D printing brings value not just to the manufacturing process, but to the business process. It's not just a technical solution, it's a business solution as well. And at Schivo 3D, we see ourselves as solution providers. What we're interested in is working with companies to identify where they have issues, so we can use our technologies to help deliver solutions. And finally, I'd like to say we've got a special event next week, next Monday in Galway, at the Clayton Hotel. If anybody wants to come and join us, we've got Dr. Phil Reeves from Stratasys Strategic Consulting joining us. So everybody is welcome. Monday morning, Monday afternoon, 2 different sessions, Clayton Hotel Galway next week. Thank you. Any questions, or is everybody going to rush home?
If you would have to pick one industry which would be disrupted most by the 3D printing, which one would it be?
It would be aerospace. It would be aerospace, absolutely, because I was in a meeting last week with Airbus, and they have a 9-year backlog. If you want to order a plane today, you've got to wait a minimum of 9 years. There's a lead time issue with the 3D printing materials. There's also the weight issue. You're going to build parts much more quickly, but much lighter as well, so the cost savings are absolutely immense. The big barrier to aerospace continuing take up of 3D printing, and it's something that's coming. I mean, the story about the Airbus A350 XWB, that's a newsworthy story because there's 1,000 parts flying in the sky. But in 10, 15 years, every single commercial aircraft will have 3D printed parts. The parts that were on the plane are these kind of parts. It's the ducting, it's in the media system, it's in your seat, it's above your head. They're not structural parts, they're not parts holding the airplane together, keeping the airplane up in the sky. But that's going to come, absolutely, and will really come with the types of technology that Trina is working with, that Ramesh is working with, more on the metal side than the thermoplastic side. But that's where the benefit's really going to come. And later this year, Airbus Astrium, the satellite division of Airbus, is launching a satellite that will have a titanium printed bracket, a structural bracket, so a part that will actually help keep that part up in the sky. And what we're going to see is that all the aerospace companies in the next 10, 15 years will be really, really utilizing 3D printing.